Tonight's law that we're going to be talking about is Charles's law. And what variables does Charles deal with? Well, Charles is the only first name guy, so Charles can watch TV. Okay, and so what is T and V? It's temperature and volume. So if T and V are your variables that Charles deals with, the things that are constant would be your amount, which is N, and your P, which is pressure. Okay, so what are their relationship? Well, as volume or temperature goes up, the other one also goes up. So that is known as a direct relationship. So the graph for a direct relationship would be a straight line going upwards. What is their formula? It's V1 over T1 equals V2 over T2. The only thing that's really important is the volumes can be in any unit as long as they are the same, but your temperatures 100% need to be in Kelvin, okay, as always for all of these gas laws. So let's get some real life examples of Charles's law. The one that we're going to be talking about is the hot air balloon. So what happens with a hot air balloon, if anybody's ever seen them starting to be launched, is you look at it and they just start heating up that air. They're actually not adding any air to the hot air balloon. All they are doing is heating up all of those particles that are currently in that hot air balloon. And what do you notice when it's first starting? Well, it's flat on the ground. And as you add more and more heat to it, here's my lovely heat. What happens is that it's going to get bigger and bigger. Okay, so as I add more heat, it's going to get bigger and bigger. So as I increase my temperature, my volume also increases. All right, so let's do a practice problem. So we've got 4 liters of a gas that is collected at 50 degrees Celsius. So here is my V1, here is my T1. What will its volume be? So that's V2, upon cooling it to 25 degrees Celsius, so that's T2. All right, as always, you are going to have to convert these into Kelvin. So I'm just going to add 273 here, so that would be 323 Kelvin. And this guy in Kelvin would be 298 Kelvin. So my formula is V1 over T1 equals V2 over T2. So in this situation, we're going to do 4.40 liters over 323 Kelvin. That is equal to my V2, which I'm solving for, and my T2 is 298 Kelvin. So when we cross multiply, we get V equals 4.06 liters. All right, hopefully you kind of have an understanding of this. Remember, Charles can watch TV, okay, and it is a direct relationship. Have a great evening.